Okay, so once again, we're just using the table in reverse. So we're saying find the value of C to make it 95%. And the first one is a straight lookup on the table. The second one is a little bit trickier. Let's see if you guys are able to do that first one of straight lookup on the table, the value of C so that Z is less than C. Okay, 1.645 plus minus 2 decimals. This little 2 in bold means within 2 decimals. If you look up 1.64, I think is a little bit less than 0.95, and 1.65 is a little bit more than 0.95. So that's the right value. 11 people said 0.8289. Gary, what mistake did they make?
They have looked up a Z value of 0.95, I would bet.
Okay, let's bring this up. I'm trying to figure, because if 11 people made the mistake, we got to understand what went wrong.
If I look at 0.95, I find 0.8289. Can I get the dot cam?
Bringing it up.
Dot camera.
There you go.
Dot camera. So, they looked up 0.95 as the Z value and found that the area was 0.289, but it's the area that was 0.95, and we wanted the Z value. So
they got it backwards.
You didn't flip what we were looking for. Right?
Amazing. Okay, good. I'm glad we figured it out. So 11 people made that mistake. Don't make that mistake on the final exam.
Right.
Where are we? Okay, so yeah. So the answer is this C value is like on the x-axis, and the area under the curve is this number. We said find the value on the x-axis to make the area 95.95. These people got it backwards, and they had it. They looked up the. Okay, they outputted the probability that Z is less than or equal to 0.95. Okay, great. No other common wrong answers. The one I'm really curious about, this one, is not on the table. You got to do something a little bit clever and figure something out, and that's because it has to do with this absolute value function. So I wonder if there's a consensus here of what people did. Let's see. Hoo-hoo. Hoo-hoo. No, there is not. Okay, so let's talk about this one. The absolute value of Z less than something. That's not on the table. You have to know a little bit about absolute values, which we talked about last class. Let me remind you about the absolute value, and I'll give you guys a chance to revote and look this one up. So let's do it quickly here on the dot cam. So the thing that we're doing is, the thing that you need to know is that the absolute value of Z being less than something, in this case let's call it S, that is the same thing as Z is between S and minus S. And the very end of last class, we did the probability, we calculated the probability that minus 1 is less than Z is less than plus 1. That's what we did last class. Am I on the dot cam? Okay, great. 1.0. And that's not on this table. That's like a two-sided thing. So that would be like an area that looks like this. An area between minus 1 and plus 1, this shaded area. And that's not on the table. But the good news is you can do this by using symmetry. So what is missing over here, the area missing is the same. So same area on the left area, and the right area, the left equals the right. So what is this area? It is the probability that Z is less than or equal to 1.0. That would be everything over here on the left. Let's see, what do I want to do? I want to do 1 minus. So 1 minus this is the right area, or the left area, equals 1 minus the probability Z is less than or equal to 1.0. And that is on the table. And so what is this answer? It's 1 minus twice that. So let me write it like this. It's 1 minus left minus right, which is 1 minus twice 1 minus the probability is Z is less than 1.0. Okay, now my writing is getting small here because this is the problem with physical paper. Okay, fortunately we have a solution. We zoom in. Okay.
Or you could go 1 minus the probability Z is less than negative 1.
Yeah, you could do it the other way.
1 minus 2 times the probability Z is less
Yes,
than
okay, so let me do it this way. All right, a 1 minus a 2 with a 2. So this is 2 times the probability Z is less than 1.0 minus 1. Or as Gary's pointing out, you could have done it the other way, and you could have said, hey, that left-right area is just the probability that Z is less than minus 1. That's also totally legit. And in that situation, you'd get that the probability that you're between -1 and 1, that's 1 minus the left minus the right. And in this situation, it's 1 minus 2 times the probability z is less than minus 1. So there's this funny little 2x conversion between the middle areas, which come with an absolute value, and the tails, the left and right tails. We did this all last class. This doesn't tell you exactly how to do this answer, but if you understand what's going on here, you should be able to get that one as well. Are there any questions or comments about this approach from last class? There's 2 ways to do it. You're basically chasing down areas. You know the symmetry. You know L equals R. You know the total area is 1, and you're just like using all these facts. It's like you give a 4th grader, and you're like, find the area of these shapes, and they like puzzle it together however they can.
Mihai?
Yes?
Should we set up a graph for what they're trying to solve?
Well, I think that we should just set them loose and see if they can do it.
Okay, let's do that.
Because I think they can do it. So we're going to go back. I'm going to open this up again. So I'm going to give you a second chance to do it. Duplicate. And then here we go. You have it again. So now you can try to do it again. And it's open now. So please take a minute and try to do it. There you go. All right, and feel free to discuss with your neighbors. Maybe we should keep this doc cam open on the other side so people can use it, and have a minute or two to try it out.
This course is only 11th, right?
I could not tell you. We could try to look it up, yeah.
I got it on my phone.
Sure.
I got 3 exams, so I get them confused as to which one is where. Put that down too. Just take a look there. Yeah, this one's the 11th.
Okay.
Which is kind of good. Gives more room for getting practice questions in on that.
Sure.
Yeah.
Okay, but before I close it, so if you have an answer, don't feel rushed to answer. Let me start giving some hints for people who are a little stuck. So I'll use the colors for the hints. Okay, let me stop the annoying timer. So here comes the hint. So we have our beautiful graph. I don't draw them as good as Gary. Gary's got.
Off the.
Oh, nobody can see the graph. Okay.
Off the dot camera. You're off the dot.
Oh, I see. Okay. Good. Okay, great. There we go. And we're looking for the value of C. We're looking for the absolute value of Z. Oh, I called it S, didn't I? S.
Yeah.
So S, that is the same. The first thing you got to know is just between S and minus S. If you're taking Math 1200 calculus, you are tortured by these absolute values and when you do epsilon delta, and now it should be easy. But okay, so there's an S and a minus S, and we're talking about this area in the middle. Okay, great. And what do we want? We want this area, the probability is the area, that we want the probability of this area to be 0.95. If that is 0.95, then that means that what is left over is 5%. 5% left over. 0.05 left over. And if 0.05 is left over, that means that there's 0.025 on either side. 0.025. So the left equals the right. Oh, this is the right side, isn't it? Okay. Left equals right equals 0.025. And I know they're equal, and I know they add up to 0.05, which is how I found that they were each 0.025. And so now the question is, where on your table do you look that up? Okay, so now hopefully that's enough of a hint. Let me give like 30 more seconds, and then we'll take it up. I think most people have answered. And we'll see how we did this time. Okay, 2 seconds left. Put in your final answer, and we're going to take it up. Okay. What did we get to? Reveal counts. All right, everybody did the first part right. Very good. Well, most people. And in the second one, the most common answer is 1.96. Although only 22 people got it. So maybe we should go over it in some detail. Why is it 1.96? What should happen when you look up 1.96 on the table is you should see that the area either below negative 1.96 is 0.025. Oh. The timers are running amok today. Okay. So let's look up on the table and see. So 1.96. You can either look up plus 1.96, which would be 1.9 is here, 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 is 0.975. So that is saying if you look all the way at z equals 1.96, then this area is 0.975, and the leftover area is 0.025, and that is exactly what we want. So this is half of the amount that we wanted, and that's because we wanted the two-sided thing. We wanted each half to be 0.025, so we want s equals 1.96. So that's kind of how I would logic it out, kind of comparing these two pictures. The one I drew is the one that we want, and the one we have is the one from the table, and they match. They both give this area of 0.025 left over. So that's why that one works. You could also look at s equals negative 1.96. If you do that, that's on this side of the table. Negative 1.96, 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and that's 0.025. Oh, that was 0.5. Okay, I counted it wrong. 0.025. There we go.
The trick is you're looking for the area in the table and then reading the z value rather than looking at the z value and reading the area.
Yeah, so some people, if we look at the possible answers, if you got 1.96, you got it right. If you said something like 2.8, you're probably, I don't know, did you double 1.96? I don't know if you 2.8. If you have this one, probably you looked it up the wrong way. Negative 1.96, again, you made a small mistake. You figured out negative s is that. Okay. And 0.025 is what we're looking up. So those are some of the answers. I don't know what these other answers are. Oh, these ones are close. I don't know. If you use the internet, maybe you got that one. Some of them I think looked it up backwards, like they did in the first one. So for this first one, yeah, okay, it's gone now. Okay, questions or comments? I think only about half the people got it right. Okay, it's a good one for the final exam then. See if you learn how to do it. No questions, no comments? Okay, let's move on to more stuff with the normal distribution then.
Charging on.
I'll hand this to you.
Okay, so last day we were working on these, just running through these, a couple of these very quickly. One was the probability the absolute value of z was less than 2, and you know, that was kind of not that hard to get. We did, this is almost the same thing. This could be written as the probability the absolute value of z is less than 1. This is the probability the absolute value of z is less than 2. And we could have gone to the 2 and looked at 2 and found 0.9772. And then subtracted the probability z is less than negative 2, which was 0.0228. And let me just work that out just a second. There's a reason I want to work that out. Okay, pens, things, got things up there. Okay, So, I want to emphasize one thing is you will save yourself from a lot of mistakes if you draw pictures and what you want. Okay, so I'm going to do number 5 here. We're doing number 5. And I want the probability of the absolute value of z is less than 2.00. And so I draw my picture. I draw, you get not too bad at drawing bell-shaped curves. And these are standard normal distributions, so the mean is 0. And so remember, again, that the points of inflection are at plus and minus 1 standard deviation from the mean. And so 2 is going to be up here. It's going to be a small number. And similarly then with the absolute value, there's also a negative 2. And so what we want to get is this area in here. Okay, so again, shade in the area you want. So the only area we don't want is this kind of small thing, and I use a Mihai's notation. There's the left tail and there's the right tail, and they're going to be equal. And so we just got to get rid of those from the total area of 1. Now, various ways of going about doing that is one solution is to take the probability z is less than 2 and subtract the probability that z is less than negative 2. That's one solution. Another solution is to do 1 minus 2 times this area here, or 1 minus 2 times this area here, since that area is the same as that area. You've got more than one way of, well, there's a term which is kind of gross, which is that there's more than one way to skin a cat, but we really do not want to skin cats. Just the whole thought of it is disgusting. So 0.9772 minus 0.0228. Oops, 0.0228. And I need my trusty calculator there. Well, let's imagine that I need my calculator there. I actually know what that number is because it's kind of a famous number. 0.0228. Okay, so it's 0.9544. Okay, 0.9544 is within plus and minus a z of 2, and we'll see that that corresponds to 2 standard deviations from the mean. So about 95% of the observations are within 2 standard deviations of the mean. Now we could ask ourselves, well, exactly where do we get 95% of the standard deviations from the mean? If we calculate the probability that z, the absolute value of z, is less than or equal to 1.96, we find that is equal to 0.95 to at least a couple decimal places, a couple extra decimal places. It's not exactly, but it's 1.96 standard deviations gives us 95% of the observations. So these are kind of standard ones. That's a common one. 2 standard deviations approximately 95%. 1 standard deviation is about 68%. When you go 3 standard deviations, you're up to about 99%, 99.7%, which means almost all your observations are within 3 standard deviations of the mean. Now, there's one other in here, which is the probability z is less than negative 5.2. This one right here. And you can kind of see Dr. Balka's tables are very, very good. And in fact, there's negative 5 out there. 0.000000, I don't know, I'm not sure how many zeros I said, 3. The idea is once you get far out in the tails, the probability of being out in those tails is extremely small. And so to like 4 decimal places, those probabilities are 0. If we said what's the probability that z is less than negative 10, you would just say approximately 0 or less than 0.0001, something like that. It's not exactly 0, it's just getting extremely small. Now, and we worked out this one here as our mathematized exercise for today, and that was 1.645 was the answer for that one, 1.645, and so we got that. Okay, so the thing is you have all kinds of normal distributions. The standard normal distribution has mean 0, standard deviation 1, but what if I want to approximate, say, the heights of people with a normal distribution? Well, they don't have a mean of 0 and a standard deviation of 1. They've got some other mean. They've got some other standard deviation. The trick is we can transform any normal distribution to a standard normal for the purpose of looking up probabilities. And what we do is we do this thing called a standardizing transformation. Z equals x minus mu divided by sigma. Now, a couple little bits about this thing is, first of all, when you do x minus mu, you are centering the mean to 0, and then dividing by sigma gets to the point of saying how many standard deviations are you from the mean. So we'll try to illustrate what I mean by this in a second. So let's find the following for a normal random variable x with mean mu equals 60 and standard deviation equals to 10. And the probability that x is greater than 65. I'm going to start off with the probability x is greater than 65. And I'm going to show you a technique which will ensure that your error rate gets extremely small. And when you try to save time by not drawing pictures, your error rate gets incredibly high. Okay, so we're doing, we want the probability x is greater than 65. So I draw two pictures. I'm going to draw two pictures. This is x. This is the distribution of x. Mu is equal to 60. Standard deviation is equal to 10. And so let's just draw there. There's the mean of 60. Standard deviation of 10 means that its points of inflection would be at 50 and 70. And so the points of inflection at 50 and 70, there's 70. So 65 is about right there. There's 65. And what I want to do is I want to find this area right here. Okay? And what we know is when we make this standardizing transformation, z equals x minus mu divided by sigma, it's going to take us to a standard normal distribution, which looks the same, except the mean goes to 0, and the standard deviation goes to 1. And so where this was 70, this is going to be 1. And so the 65 is here, and we're going to get that z value in a moment. But the point is that this area here is going to be equal to this area here. Now, what is this z value? I'm going to call it a z naught value. I'm going to, well, we're going to get that in a second. I can call that z. Okay. So the probability that x is greater than 65 is equal to the probability that z is greater than 65 minus mu divided by sigma. It's the probability that z is greater than 65 minus 60 over 10 is the probability that z is greater than 0.5. So this z value here is equal to 0.5. That says that that z value is a half a standard deviation above the mean. And we want this area above here So we say, oh my goodness, that is so easy. Then we got two solutions. You can do 1 minus the probability that z is less than 0.5. And so I'm going to do this, and then I'm going to show you one slightly quicker solution. 1 minus the probability z is less than 0.5. Oh, go to my table, find 0.5. 1 minus 0.6915 equals, what have we got? 0.3085, I think. If I did the math right in my head, 0.3085. Or it's equal to the probability that z is less than negative 0.5. I'm using the property of symmetry, that the probability that z is greater than 0.5 is the same as the probability z is less than negative 0.5. So I don't even have to do a subtraction. I can just go to the table and I find, oh, there it is, 0.3085. So there's a couple solutions. There's a solution, right? Oh, sorry. People, you gotta let me know if I'm off the dot camera. There. So any questions on that one? Yeah.
Why did you subtract it by 1?
Why did I subtract it from 1? Because when I looked up 0.5 on the table, that gives me the area below z. Because remember, it's cumulative tables up to z, but I want the area above z. I know the total area under the curve is 1. The area below 0.5 is 0.6915, so the area above 0.5 has to be 1 minus that is 0.3085. Or the trickier one is to do the flip, which is to say, hey, the area above 0.5, it has to be the same as the area below negative 0.5, and I can just look that one up directly on the table, right? Okay, similarly, you can look up the probability x is less than 45. Okay, so here's why I'm going to try to emphasize the importance of the diagram, is you got to know where you are on the graph. So we're going to do probability x is less than 45. And the first thing is, draw my distribution of x. Okay, there's x. Again, the mean is 60. And here's a critical thing, and here's what people mess up when they try to do it in their head without drawing a picture, is that you have to recognize that 45 is to the left of the mean. If you kind of think it out, 45, the standard deviation is 10. That's 1.5 standard deviations below. So 45 is going to be about right here. In many ways, it's not really critical where you draw the 45 in there, as long as you recognize it's to the left of the mean. Okay? Everything works out if you can get that left. And so what do we want? We want this area right here. That's what we want. And so the first thing, a couple things is first of all, the area is going to be less than a half. It's some sort of relatively small value, but definitely less than a half. And I can tell you, you would not believe how often on multiple choice questions people will pick an answer which is greater than a half, which means they did not even recognize that the 45 was less than 60. And 45 is less than 60, but your brain can do weird things when you're kind of not following it. So again, making this transformation, z equals x minus mu over sigma. I go from there to there. And so there is a z value here, which corresponds to that 45, where this area is exactly the same. Exactly the same. And so the probability that x is less than 45 equals the probability z is less than 45 minus mu divided by sigma, which is the probability z is less than 45 minus 60 divided by 10 is the probability z is less than negative 1.5. And that makes sense. You see, 45 is 15 below 60. The standard deviation is 10. So it's 1.5 standard deviations below. And so I now go in and fill in that this Z value is negative 1.5. And once I do that, I go to my tables. I'm all excited. Oh, I'm so excited. Negative 1.5, and that's going to be 0.0668. Right? So you're just using your your knowledge of the idea that the total probability under the curve is 1, and you are getting the area of a piece of that area under the curve. Okay, what else did we have? Oh, my goodness. What an obnoxious question. Based on my experience, lots of students can't do this question. But let that not be you, because it doesn't have to be you. There's a little X naught, but so will be. Okay. So again, the idea is to set up the diagrams. Set up the diagrams. That gets 5 exclamation marks. 5. Not 4.
It's a lot of factorials.
I could have gone 6, I guess, to emphasize it, but it's probably enough. So I'm drawing my 2 side-by-side diagrams. Okay. Yeah, perfectly, yeah, not exactly, but nonetheless. And that transformation is Z equals X minus mu over sigma. And so let's see what we know. We know that the mean of this distribution, this is the distribution of X, that's 60. And the standard deviation is 10. Yeah, that's about all I know right now. So I know where the points of inflection would be at 50 and 70, but that's about all I know. And we know the mean of this one is 0. This is the distribution of Z. So what else do I know? Well, it says the probability that X is greater than X naught is equal to 0.90. Now this is tricky. When you see the X is greater than X naught is 0.90, that means you've got to have 90% of your area to the right of X naught. And so this means this little sucker is going to be somewhere down here, such that I got a total of 0.90 up there and 0.10 down in that tail. Now that 0.90 is going to split up into 0.5 on that side and 0.4 on that side. Add an extra 0 if you like to use lots of ink from your pen. And that's where the X naught is. Okay, so this is the key thing. Here's your X naught right there. It is right there. Okay, so how are we going to solve this? Well, when we go to the standard normal table, there is a Z naught such that there's 10% in that tail and 90% above it. But the critical thing is that there's 10% in the lower tail, and what we recognize is because the Z naught is to the left of 0, it must be negative. And so we go and look for what is the Z naught that gives us 10% in the lower tail. Okay, so this is where I now start zipping through the table, and I got to figure out where 10% is. And so 10% is 0.01. No, it's 0.1. It's 0.1, not 0.01. 0.1, 0.1. Let's just see. These tables are a little, yeah, they're kind of a little problematic. Well, there's the closest we can come. Okay? So you're never going to get, rarely are you going to hit these things exactly. What you do is you pick the closest value. If it's dead in between two, you can average the two. But this one here, let's see. You see there's negative, you got that? Negative 1.003. And then I read this off, and I see that that says negative 1.28. So, I go over here, and this Z naught is going to be negative 1.28. Okay? Everybody good up to that spot? Let me just check that everybody's good where I got that negative 1.28 from. And again, it's absolutely critical that you recognize that this, because the 45 is to the left of this mean, the Z naught is going to be, that corresponds to X naught is going to be negative. And so since Z equals X minus mu divided by sigma, let's just take a look at this. X naught is going to be equal to mu plus Z sigma, Z naught sigma. Okay? So just rearranging things in terms of X. And then I go, so this is going to be 60 plus negative 1.28 times 10. And let's see, 12.8, negative 12.8, what's that going to be? 47.2, 47.2? Did I work that out right? 47.2. Then here's the next thing to do. Go back and say, does that make sense that this value is 47.2? Yeah, it seems reasonable. It's to the left of the mean. If you come up, often the people will get their sign wrong, and suddenly they're adding 12.8, and they come up with 72.8, and you go, can this value be 72.8? It can't be 72.8. It's got to be to the left of the mean. Okay? So we got some practice questions on the homework coming up, and well, there's more we can do on solving various interesting things with the normal distribution. So questions? Oh, no question? Yeah.
How did you get the X naught equation?
Where did I get the X? This one right here?
Yeah.
By rearranging this. Okay? So if you want, you could, since that equals X minus mu over sigma, I guess I could put the following, that Z naught will be equal to X naught minus mu over sigma, and then I just rearranged it for X naught. Is that good? Okay. What did I just do? Hey, how do I get that thing back again? Oh, those were just the answers. I just put out the answers. That was all. Okay, going to show you a couple more things. Fun things here. Oh, this is going to depend on my internet working. Oh, man. Oh, this is so shaky. So shaky. So, I'm going to see if I can get... I'm going to see if I can get StatTrek working. So uncertain. Go. Oh.
All right, I'm trying mine.
Try yours, eh? Why is this thing so obnoxious?
What is it? Online calculator?
It's supposed to work automatically without signing into anything. Okay. So Mihai is going to show us what he can do with this fine calculator here. First of all, by default, it gives you a standard score, and that'll give you a probability. So let's suppose we just put in a standard score of 1.96.
Hold on, I want to put in 0.
You put in 0.
For the record, Gary's saying I'm going to show you. This is my first time ever on this website. Okay, hopefully it does. What do we think it's going to do if I do 0? Hit calculate. You should know what it's going to do. 0.5. 0.5. Oh, yeah, that makes sense. Got the bell curve in the middle. 0.5. Okay. That establishes my sanity in the world. Okay. What do you want to put in? 1.9?
1.96. What answer should we get? We worked it out earlier. Mathematize.
This one's tricky because 1.96, it was either 5%, but I don't remember if 5% is the 2-tail or the 1-tail.
Well, it's also given, notice what probability it's given you.
I haven't typed it in yet. I haven't hit calculate.
Okay, and you got to wipe this. You got to clean this out first.
Oh, okay. Well, I'm sure if I hit calculate, it'll put it in. Okay, but let's hit calculate and see what it does. You guys probably know better than me what it does.
I know what it does.
Well, of course you know what it does.
Too many inputs. You got to leave it blank. It's got to have something to calculate.
Oh, I see. Okay, so you put in 3 out of 4 blanks.
Yes.
And then you hit calculate. Okay.
Yes.
0.975. Okay, so as the...
Okay, let's wipe out this one, the 1.96.
Wait, but I want to make sure my sanity is preserved. So 1.96 has 5%, like the absolute value being 1.96 was 5% outside, which means 0.025 on the left, 0.025 on the right, and this is the one-sided, less than.
That's the
90.
cumulative probability.
Great. What do you want me to clean out? This one?
I want you to clean that out.
Okay.
And ask it, what are you going to get if you give it a cumulative probability of 0.975?
Oh, well, it should put back what we had a second ago. Huh. Oh, ooh, it gave us more decimal places. That's exciting.
It gives you more decimal places.
Ooh. What an amazing piece of technology.
It is an amazing piece of technology. Now, we just worked out a diagram here where we were trying to find what x naught was. Let's give it a standard score.
Ooh, we can put in the 60 and
the 60 and 10.
60 and 10.
Okay, 60 and 10. And we
want the
10%. The cumulative probability to be 10%.
Do we want 10 or do we want 90?
I want 10.
10. But the question said 90.
Well, that was in the upper tail. But it asked for the lower tail.
This one, because the less than here, it's always the lower tail. Okay, got it.
And we're going to clean this out. So it's going to give us the right answer.
Calculate. 47.18. What did you get, Gary?
47.2.
That's pretty close.
Yeah, we got a little bit of issues with the Z table.
What if you torture this thing? What if I make the probability 2? Then what will it do? Too big.
Too big.
All right, what about -7? Too small. Oh. Okay, what if I don't know, how else can I torture it? 0.
You got to leave something blank. You always got to leave something blank.
0. What is it going to give me for 0? What x value would have a probability of 0? This is exciting. -infinity. Oh. All right, that's good. That's very nice.
Yeah, because you got your mean up.
They've thought of everything. Okay.
They've thought of everything.
Oh, what if I put in a negative standard deviation? Too small. Oh, okay.
Well, it's more than that. Yes, but okay.
Okay.
Let's go with that.
Great. So this will help you do your homework. Of course, you won't have this on the exam because the exam is paper only. So make sure you know how to do it at the table as well. The question on the exam will ask you to do it at the table. All right.
Or maybe R, which we're going to slip in at some point.
Any questions or comments before we go? All right. Have a fun Wednesday evening.